Uh, this is example 4. A pitcher throws a ball to a batter who hits the ball to the shortstop. If the ball travels in a straight line between each, what is the total distance traveled by the ball? Round your answer to the nearest foot. So we have a pitcher throws the ball to the batter, so we need to find that distance. Let's call that D1. And then we have the batter hits the ball straight to the shortstop. So let's call that distance D2. Right. So probably should have done a different color there. Let's do it in blue. And we'll call that D2. So let's start with D1. We're looking for the distance between those points. So our 2 points here are going to be 0, 0. Right, that's where the batter is. And then our pitcher is at 5, 5. So those are our 2 coordinates. We're looking for the distance between them, so we use our distance formula. Right? Our distance formula was x2 minus x1 squared plus y2 minus y1 squared. Right, so we have distance equals x2 and x1, so that's going to be 0 and 5. Again, you can make this first one x1, y1 if you want, and x2, y2, or you can do it the other way. It doesn't matter. So I'm just going to do it the way I have it written. So x2 is 5, x1 is 0, so 5 minus 0 squared. And then y2 is 5, y1 is 0, so 5 minus, again, 0 squared. So that's going to be 5 minus 0 is 5. 5 squared is going to be 25. 5 minus 0 is 5. 5 squared is going to be 25. And you can see if you did it the other way, 0 minus 5, that's going to be negative 5. Negative 5 squared is going to be a positive 25. So that's why it's not going to matter which way you do it. Okay, and then 25 and 25 is 50. Square root of 50 is going to be approximately 7.1-ish. Right, square root of 49 is 7, so it's going to be just more than 7. It might even be 7.0 something, but approximately 7.1. Okay, that's the distance the ball traveled from the pitcher to the batter. That's what we call D1. Right, that was our first distance. Okay, now we need to do D2, our second distance. So we have points 0, 0. And we have points 5, 10. Those are our 2 points. Again, I'm just going to make 0, 0, x1 and y1. And then I'm going to make 0.510 our x2 and our y2. All right, so our 2 x coordinates, again, we're now finding the distance from the batter to the shortstop. So it's the same formula as over here, x2 minus x1. So our x values are 5 and 0. So again, just like the last one, it's going to be 5 minus 0 squared plus our 2 y values, y2 minus y1, that's 10 minus 0 squared. So we have square root. 5 minus 0 is 5. Squared is going to be 25. 10 minus 0 is 10. Squared is going to be 100. So D2 is going to be square root of 25 plus 100. So that's 125. Square root of 125 is approximately 11.2. So approximately 11.2. So we want to know the total distance the ball traveled, so we're going to have to add those together. So 11.2 plus 7.1. That's going to give us 18.3. Struggling here. Okay, and that's units. It wants us to do to the nearest foot, though. So each unit is going to be 9 feet. So we're going to then have to multiply this by 9, right? So this is units. And we have to convert. So let's see if we write it up here. So 18.3, right, units. All right, for every 1 unit. I don't know why it got hard to write here. Is 9 feet. So 9 feet. So if we do our stoichiometry here, we're going 18.3 times 9 divided by 1. So 18.3 times 9. So we're going to have to use our calculators on that one. 18.3 times 9 is going to give us 164.7 feet. And that's our distance traveled. Okay, so we had to use the distance formula twice.